Hi guys, welcome back to my channel. Today I want to talk about IR. And IR stands for infrared spectroscopy, right? Why do we use IR? What does that do for us, right? So as we remember from our organic chemistry lab class, we always use IR to identify the functional groups of certain molecules, right? So if this stretch shows on the IR graph, then we say, oh, we do have this functional group, and then we can further infer, oh, we do have this molecule. It's in our product. Our experimental was successful, right? So that's what IR is for. And then really this infrared light is because this technique measures the absorption, the molecule's absorption of infrared light. And then the light will cause molecular vibration, right? Either stretching or bending or twisting or folding, okay? So that's why on the x-axis, you see this wave number. Wave number is basically 1 over lambda, and lambda is the wavelength, right? Whereas on the y-axis, you see transmittance. So that is the measurement of the molecular vibration, the AKA stretching, right? Okay, so back in the day when I took OChem lab, I hated this, but I got through, and then I thought I don't need this for the rest of my life until I started to study MCAT. And it was annoying again for me to memorize a few numbers that I have to memorize for MCAT, even just a few numbers, but I didn't like looking at this chart, okay? So this is some graph that you've seen so many times, right, throughout your college course. But I mean, let's today just switch our mindset. Let's just do it differently. See how we can just really memorize these couple numbers, these few numbers that we have to memorize for at least until the end of our MCAT test, okay? All right, so I don't want you to look at this. This is so annoying, okay? Usually students will like, oh, OH is 3200 to 3400, and then C double bond to oxygen is 1650 to 1800. It is just annoying. Isn't that annoying to memorize such tedious thing, right? So today, let's just switch our method. So I will share a technique with you that I use to never forget about this again, okay? So the trick is, forget about the graph, just memorize two numbers first. So one number is 33, okay? You can do that, right? 33. Another is 17, okay? 33, 17, okay? When I was 17 years old, I was dreamed about becoming a doctor. And then when I turned 33, I graduated from medical school. I don't know, whatever, make up a story, okay? 17 or 33. And then we're gonna add 100, okay? Just add that in the back of your mind. Okay, so 3,300, what about 3,300? Oh my gosh, this is one of the most important numbers you can imagine in terms of IR, right? Because that is the peak for the alcohol group, OH, okay? That you might already know, so it doesn't take memorization, okay? But still, just forget about the functional groups, memorize two numbers, 33 and then 17, okay? Okay, so then 33 is about the famous alcohol. And then I wanna give you a side note that alcohol, when you see on MCAT, it's not just like those simple alcohol molecules, but also like phenol or cyclohexanol, right? Phenol is this benzene ring that's attached to OH, okay? You see phenol on MCAT, you look for 33, okay? And then also, what did I say? Cyclohexanol. Okay, so this is just a ring, not a benzene ring, attached to OH. Also, when you see cyclohexanol, look for 33. Okay, so that's about 33. Okay, there's another thing we have to know about 33. We'll come back. Okay, let's move on to 17. Okay, so what about 17? What about 1700? It's another thing it's another functional group that was your best friend, right? The COO carbonyl group, right? This was literally my best friend when I took OChem 2, okay? And then by saying carbonyl group, I mean a lot of things, right? I mean ester. I mean amide. What else do I mean? I mean aldehyde even. And then I also mean ketone, right? Different R can give me different molecules, but they all share what? COO, carbonyl functional group, right? So that's 1700. That's 17, okay? And then as you can imagine, 32 is larger than 17. So on the OH stretch, will more be on this leftward, if you will, right? So it's like a super broad curve, right? Peak, if you will. Okay, and then 17 is more like on the right side, and it's not as broad as the OH, okay? All right, so far so good. We're just memorizing 4 things now. 33, 17, we already got it. And then OH and carbonyl, we already got it, okay? We're good. Okay, now I'm gonna expand it a little bit, okay? Not too bad. But before we expand more to something else we need to know, do you wonder if carboxylic acid does that give us a OH stretch or carbonyl stretch? Is this OH part of this R? Actually, no. Okay, so carboxylic acid is a unique thing that you look for 2 functional groups, a combination of 33 and 17. And then the 33 component is the OH here. The 17 component is the carbonyl here, okay? So you would see something like that, okay, on MCAT for carboxylic acid, okay? So far, we're still just memorizing 4 things, right? 33, alcohol, 17, carbonyl, and then carboxylic acid is a combination of all this. Okay, now I'm going to expand 33 a little bit for you, okay? I want to shrink this. Okay, I'll just move it up. Okay, so there's another functional group you need to know regarding 33, okay? Which is amine. It's not too bad, right? Alcohol, amine, okay? They are all single bonded. They all have sigma bonds, right? All right, so what about amine? So amine is also really close to 33, right? It's a little bit tiny on the leftward of 33, but it's okay. Just remember 33. You don't have to expand it to 34, 35, okay? So 3,300, but the difference of primary amine and secondary amine is, as you know, that primary amine is attached to 2 hydrogens, right? Whereas the primary amine is just attached to 1 hydrogen. So because of this characteristic of attaching to 1 extra hydrogen, then the primary amine, you will see really like 2 subpeaks, okay? So you will really see something like that, okay? So that's primary amine, 2 subpeaks, okay? Whereas the secondary amine, it's attached to only 1 hydrogen. So really it's just something like that, really close to the alcohol stretch, okay? That's it. That's all you need to know about the 33, okay? OH and amine. And an amine has primary, secondary, primary, it has 2 subpeaks, okay? That's it, okay? And then, I want to give you a bonus one if you think that you have the capacity to memorize another thing, which I think you do, which is for our 17, we also have this C double bond, okay? They are also a little tiny bit on the leftward of our traditional carbonyl 1700, but they are there, okay? So that's it. And then the last bonus is I want to remind you that ester doesn't equal to ether, okay? Ether is this thing. It's not a carbonyl group thing, okay? It doesn't have any pi bonds. It's just ether. And then it has a really, some number that's not 33 and 17, so you don't have to know that. Anyways, ester does not equal to ether, okay? So that's about it. And then did you notice that on the, like I say, leftward of the picture, that these are all the sigma bonds, right? Single bonds, whereas towards the right side of our graph, it's more like those double bond characteristic, like our carbonyl and then this CC double bond, okay? I hope that's helpful.